Integrated Science. This is Mr. B, and we are going to continue on with our astronomy unit. This section is going to focus on the inner solar system. The last section just kind of focused on the Earth and the Moon and how they relate to one another. So now we're going to take a look at some of the other planets that kind of fall within what is called the inner solar system. And they started off this section kind of giving some examples here. So they talk about how this imaginative painting shows what a future settlement on Mars might look like, saying that they might need to live in a dome to protect themselves from the harsh climate, to provide an atmosphere for breathing. And that is kind of the source of a lot of science fiction, a lot of things going on about humans colonizing Mars. So this, again, just to kind of give us a little introduction, this what a possible settlement might look like. Again, very futuristic looking there, but obviously that is not a real image. But to actually start with some of the content that is in this section, they talk about how are all the inner planets similar. So again, one of the big key concepts that all these planets that fall within the inner solar system, some of the things they all share in common. Again, they're all relatively small and dense and have rocky surfaces, which that's a big thing. They're going to talk about terrestrial planets here in a moment. And then like Earth, they all have a crust, a mantle, and as well as an iron core. Again, those being all the different layers in the Earth, which again I know it hasn't been this year, but I know for a fact at some time in your science career you have spent a lot of time talking about those different layers. So the terrestrial planets, again, and Terra, I know this was an English word for some of you guys. Terra means Earth, so kind of like a rocky planet. That's kind of where that terrestrial comes from. They're similar to in structure to Earth. There's Mercury, Venus, Earth, and Mars are our four terrestrial planets. And again, they all have rocky crust. That's a big thing with this group. They all have rocky crust. So that'd probably be a question you might need to know to the quiz, is something that all terrestrial planets have in common. They have a rocky crust. Mercury and Mars have surfaces with a lot of craters on them. And most craters on Earth and Venus have disappeared because their surface is continually being altered. Again, we talked about that kind of with the Moon, how there's no plate movement, there's no erosion on the Moon. So similar things are kind of going on there with Mercury and Mars, that once they get hit by a crater, there's no forces changing the surface of the Earth to cause those craters to disappear. And then a couple other things about the terrestrial planets: they're much warmer on average than the outer planets because they are in fact closer to the Sun, which hopefully that makes a little bit of sense there. And then within the inner planets, very few, if any, have a moon. Again, we have our one moon. Again, we'll get to if the other ones have moons as well, because there are some, but not a ton. And then none of them have rings. So Saturn is kind of one of the most classic examples of rings on a planet, and that is going to be in the outer planet, where the inner planets have no rings whatsoever. And this chart, don't worry about writing this chart down now. This is just kind of giving some of the big overview, some of the different characteristics of the planet. Again, how big it is, like kind of its diameter, the average distance of the Sun, the rotation, revolution, number of moons. This might appear on a test. I would give you this chart and have you answer questions about it, but I'm not going to really have you memorize this chart at this time, so don't worry about writing that down. So to start, to get in with our actual planets of the inner solar system, we're going to take a look at Mercury. Mercury is the smallest of the terrestrial planets, and it is in fact closest to the Sun. So we're going to start kind of at the Sun again, because that's our heliocentric model there, and we're going to work our way out. Mercury is a dense planet, again meaning very kind of compact there, with a very large iron core. So again, it's not very big, but it is kind of a lot of things jam-packed into that small space. There is no mantle convection within the planet, and then there's therefore little erosion on its surface, to kind of go back to the time about a couple slides ago where we just talked about how there's a lot of craters on Mercury, and that's because there's no mantle convection or erosion, so that results in a lot of craters. And it takes only 88 Earth days for Mercury to complete one revolution, and revolution is how it revolves around the Sun. So one Mercury year is equivalent to 88 days. So this is the shortest period of revolution of any planet. So again, on Earth, our revolution takes 365 Earth days, and Mercury, their one Mercury year is equivalent to 88 Earth days, because that's how long it takes to complete one revolution around the Sun. So that's what revolution means. They're kind of their plane that they take around the Sun. Mercury's surface, again, heavily cratered from meteoroid collisions. This false color image, so this is not what the actual color of Mercury is. They added this color to kind of give more distinguishing features there. Again, they combined a bunch of series of smaller images taken by the Mariner 10 space probe, and these orange areas over here means there's no images available that they were able to gather. Again, this section right over here, this little section right here, so those were left blank because the images that the probe took did not really capture them. Mercury's surface temperature is very extreme. During the daytime, it can, at the equator, which is kind of their most central line running around the planet there, 430 degrees Celsius, so extremely, extremely hot, to where at nighttime the temperature can drop as low as negative 170 degrees Celsius, so extreme, extreme temperature shifts there. And again, the time between sunrise and sunset equals the time it takes for Mercury to revolve around the sun, which is about 88 days. So again, one sunset, the time the sun comes up to the time the sun goes down, it takes about 88 Earth days for that to happen once. And Mercury has virtually no atmosphere whatsoever, so again, not a lot of gases or anything present there. Again, they're just kind of subjected to whatever the sun is going to dish out to them. If the sun's shining there, it's going to be hot. If it's not there, it's going to be really cold because of that no atmosphere. And because Mercury is so close to the sun, it's hard for astronomers on Earth to see. In the 70s, in 74, 75, again, that Mariner 10 space probe took many images of Mercury's surface. Again, it looks a lot like Earth's moon. It's remained largely unchanged for billions of years. Again, all those meteoroid collisions are not being wiped away by like convection currents and things like that. Then there's a Messenger space probe will orbit Mercury in 2011. So again, another opportunity. Again, we're now in 2018 for you to kind of do some research on your own to figure out what did the Messenger space probe maybe even tell us about Mercury. So that could just kind of be a nice kind of jumping off point for you there if you're curious to find out more. But yeah, maybe we might talk about that more in class as well. So to wrap this video up, we're going to finish off with Venus. Venus is another one of the inner planets. Again, has a very thick atmosphere compared to Mercury's no atmosphere, and it's composed mostly of carbon dioxide, which traps a lot of heat and it's going to raise the planet's temperature. Again, just a couple interesting things about Venus. It's called the evening star or the morning star because it is only seen in the west after a sunset or in the east before a sunrise. And except for the moon, this is going to be the brightest object in Earth's night sky. So if you know where to look, you can in fact see Venus again at these two times here, again right or after a sunset or before a sunrise. And Venus rotates slowly. It rotates very slowly on its axis in the direction opposite to which it revolves, which we kind of can talk about that more. And its day is actually longer than its year. So to me, this is one of the most interesting things I learned when I started teaching this unit, is that it takes longer for Venus, to rotate once on its axis than it does to make a whole revolution around the sun. So and again, this is probably going to be a good quiz question, that its day is actually longer than its year. Again, we'll talk about that more to get a little bit more of a visualization to kind of help you understand how that is possible there. Venus's atmosphere is difficult to study from space because clouds hide its surface. It's kind of a big characteristic of Venus, is it's very cloudy. And its atmosphere is so thick that its surface is 90 times that on Earth, so much more pressure weighing down on you if you were ever able to make it to Venus, which we're going to see here that is very, 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 very unlikely because of the conditions that exist there. We did land spacecraft on Venus's surface in the 70s and found that the average surface temperature to be around 460 degrees Celsius. So again, that thick atmosphere, once heat from the sun comes in, it stays trapped in there and it just creates a very inhospitable environment that is very, very warm. And there is extremely high sulfur content in Venus's atmosphere because, again, probably it results from numerous volcanoes. The outpouring of lava from volcanoes has frequently resurfaced the planet, erasing craters as well. So again, Venus, kind of the opposite of Mercury, the opposite of Moon. They have a lot of activity going on there, so that means that their surface is going to be constantly reshaped and changed. And though Venus has active volcanoes, it shows no evidence of plate tectonics, so we don't know if, again, on Earth here, how we have our crust kind of slides along of our mantle. Again, we don't know for a fact that it's not there, but we have not observed any evidence that there are plate tectonics kind of driving some of that forces there. Again, here's again a photograph of what Venus looks like. Again, you can see the very cloudy atmosphere there. It's very hard to see the surface. Again, we can use radar to penetrate Venus's atmosphere. again, and they use data from the radar to produce, again, another false color image. Again, they just kind of added this for effect to kind of see some of the different structures of what a volcano on Venus might actually look like. So we're going to wrap it up there. Let me know if you have any questions.